Okay, we're going to talk about the Yoshitake OB-30 self-acting control valve. Comes in various shapes, sizes, and different temperature ranges, etc. But it's basically a simple temperature controller. There's no requirement for any electrics or pneumatics on this system. I'll explain that to you a little bit better shortly. It's a device that is very, very reliable. It's accurate in its controllability. It's very, very easy to use and very, very easy to install and very, very easy to commission. If you have a look at this unit here, I'll just get a bit of help here from my offsider. We'll show you how the head will be attached to the valve. Now there is a piece missing in this example. That little package that comes with each unit is bellows follower, and it must be installed at the same time that you put this on. Do not lose that bellows follower. If you're doing any service or maintenance or just installing a new one, that needs to be fitted inside this device here. I'm not going to take it out of the packet because this is a new product. Now each one of the valves comes like this, with the adjusting head on the top here, and there are various forms of the sensor and capillary arrangement, and they come in various lengths. This one will be standard at 2 meters. You can get them in 3 meters and 5 meters, and they all come with a different temperature range. So we have 0 to 35, 25 to 70, 40 to 100, 60 to 130, and 70 to 150. So there's quite a variety there to get you from certain temperatures that may be a little bit obscure. You have to pick whatever you want in between the range of the sensor, and they're all available on the shelf. Each one of these sensors and capillary will fit any size valve. So this one will go on the 15, 20 or 25 mil unit, which makes it quite handy if you need to replace one because something's broken down and you need to put a different head on it. You can take one off an existing unit and put it onto a different size unit. Typically the self-acting control valve, it's not a very sophisticated unit. The way it operates is the fluid inside the capillary heats up. So it's situated in maybe a tank of water. This would be a typical application where we would have a tank of water and we want to heat it up. We put our coil inside the tank or other heat transfer surface area inside the tank, and we put our control valve on the steam line. Now we want it to get to a certain temperature, whatever that may be, 50, 60 degrees C. The sensor needs to be mounted within the level of the water or product or other fluid, whatever it is that you're heating up in there. And with the sensor in the fluid there, as the temperature rises, it heats up the fluid or the temperature sensitive fluid inside the capillary and inside that capillary causes the heat to expand the fluid and push on that pin to move it up and down depending on the spring tension that you set it at up here to get the temperature you want. Now it's very simple to get the temperature that you might want in here, but you can't use this device to tell you what the temperature is. You'd need to have a temperature gauge adjacent to it at a similar position, similar level in the product, and when you set the temperature on there, you'd be reading it accordingly here until you get it running at the optimal temperature that you want it to run at. This temperature gauge could be a little bimetallic temperature gauge with a small sensor on the end of it, and maybe in a pocket if you need to have that. This sensor also can come with a pocket which can be mounted inside the tank. Typically They come with just a mounting bush attached on the end there, so if you wanted to, you could just weld a socket inside your tank there and screw the probe directly into the tank. For the ease of maintenance, it's always good to have a pocket so you don't have to drain the tank if it's not necessary, and you can do that on your temperature gauge as well. As I said before, they have various different temperature settings. We said this might be operating at, say, 60 degrees C, 50 degrees C. So we could pick the 25 to 70 or maybe the 40 to 100. That would be my choice for controlling the temperature in that tank at, say, about 60 degrees C. The applications for this particular valve, as it's a fairly simple unit, it's not a device you would put on critical applications, but it's absolutely perfect for heating water up in a boiler feed tank, which this sort of represents here. Could be a boiler feed tank, chemical baths, other areas where you might need to heat up lots of water for particular exercise like washdown. Preheat the washdown water before it goes into another heating process where it might have to be more critically temperature controlled for safety's sake, but this would be fine for preheating that water. You can also use it for heating up other chemical baths and electroplating tanks, etc. So it has many, many uses, but it's simple, and there's no extra wiring or pneumatics to worry about when installing it. What else can I say? The installation of it is important, especially when it's being used on steam. Bear in mind this can be used on, as steam can be the heating medium, or it could be hot water or some other hot fluid that is suitable for going through a brass valve with the stainless steel and PDF seat that it's got in it, but usually used for steam or hot water as a heating medium. They like them, well, they should be installed in this fashion here, in the horizontal plane with the cap at the top. The reason for that is, don't particularly want to have the thermal temperature sensing fluid at the top, because as we all know, heat rises and can come up through the process here and affect the control of the sensor. So when installing it, make sure it's installed in that attitude there and you won't have a problem. The bellows follower, I mentioned that before. You must not lose that, because if you don't put that back in, the controllability of the valve just won't be there. It needs to have that to locate the pin and hold it within the bellows inside this area there. There's a bellows in there, and that little follower sits in there, and that pin then becomes located in the correct spot to get the controllability right. This is typical of a steam heated system with a steam trap on it. We will go through another form of steam heating in another video shortly, where we could use the OB-30. But in this case, the other item that you might want to consider when installing something like this is a vacuum breaker on the line. If ever there was a hole or a crack formed in your heat transfer surface area, when the control valve or any isolating valve upstream turns off, the steam will start to condense in here and may cause a vacuum and suck the fluid into the coil and back up through your steam line. So a vacuum breaker can always assist doing that. You can also, will assist to avoid that, sorry. You can also put a check valve in the system as well to stop reverse flow.